We'll take a look at the graph of this polar function. 3 plus 5 cosine of theta. The window from 0 to 2 pi for theta, the biggest that this can get is 8. So we should have the x's and y's set to 8's, positive and negative. And then take a look at the graph. And there's an interesting shape. So it's got a little oval inside of this other shape. And now we need to convert it to rectangular coordinates. Well, with this, as far as x's and y's, I don't remember seeing that in algebra or pre-calculus. And so that doesn't really give us any hint. So instead we just need to use the formulas that we have for converting and see if maybe that helps. Like if this is theta, here's x, y, and r. And so if I did cosine of theta, that would equal x over r. So that would help with this. I've also got that x squared plus y squared equals r squared from the Pythagorean theorem, or r is equal to the square root of x squared plus y squared. Now notice over here on this one, if you multiply through by r, you won't have a fraction. X is equal to r cosine of theta. So if we had r times cosine of theta instead of just cosine, that would be a lot nicer. Then we wouldn't have a fraction, because the way that it is, we're going to have a fraction and the r is going to be the square root of that. So it would be x divided by the square root of x squared plus y squared. Or here's an idea: take the original function and multiply both sides by r. So multiply everything by an r, and then what that's going to do is over here give us an r squared, so we can use x squared plus y squared. There's going to be a 3r, and then there's going to be a 5 times r cosine of theta. And then replace all of the things. This gets replaced with x squared plus y squared. And then the r gets replaced with the square root of x squared plus y squared. And then r cosine of theta gets replaced with an x. And now there aren't any obvious things that we could combine. For example, this 5x can't combine with that x squared or anything. And we're not going to be able to solve for y, so we're done.